Gravity is one of the fundamental forces of the universe, and it's connected with mass. Anything that has mass has gravity. We tend to think of the weight of the Earth as being entirely rocks and magma deep in the Earth. But actually, on the surface of the Earth, as you look around, you see the atmosphere and you see the ocean and you see snowfields and polar ice caps. All of those things have mass too. But those things change much more frequently. So what we realized is if we could design a mission that was accurate enough to observe those small changes, we could actually watch the polar ice caps melt. We could measure polar ice mass loss. We could even measure how much water is in the ground after it rains. And that led us to come up with the GRACE mission. Deep in the Earth, or even on the surface of the Earth, the way mass is distributed with mountains and trenches and all kinds of things is slightly different, slightly non-uniform. So as you were to walk around the Earth, you'd actually sense more or less gravity. You'd actually weigh a little bit more, a little bit less on different parts of the Earth. Isaac Newton taught us that the amount of mass that I'm standing on top of affects the gravity where I'm standing. So the rate at which this apple comes down is a function of how much mass is below me on the Earth. So no matter where you are, what's below you will be different. So gravity will be different, and so the apple will drop at a different rate. The orbit of a satellite is highly dependent upon the gravity field of the planet that it's orbiting. So what we wanted to do was put up a satellite whose orbit we could measure incredibly accurately. The best way to do that was to observe one satellite with another satellite. So the satellites are sort of chasing each other, pole to pole, flying around the Earth. And as the first one comes up, for example, on a mountain, it feels that mountain first. So it starts to get pulled toward the mountain. But the second one isn't quite there yet, so the satellites tend to sort of drift apart. Then, of course, as they're leaving the mountain, the second one is still feeling the effect of the mountain. So they come together again. And that sort of dance that the two satellites do as they go around the Earth is what tells us what the gravity field underneath them was. Now, in addition to that, the gravity field is also changing every day, every week, every month, because water is moving all around the Earth and it's raining here or the polar ice cap is melting. So water is the primary thing that's changing. But what scientists really want to understand is not just what happens across 1 year. They want to really see that play out over many years, over decades, to try to understand what's really happening in the climate system.